Hey there. Let's talk about resolving vectors into components. Sometimes you might know the magnitude of the vector and the angle of the vector and want the components of the vector. How do we do that? In this case, our vector has a magnitude of 6.4 and an angle of 39, and we want AX and BX. Our angle is with respect to the x-axis. So we recognize that the adjacent side is the x component and the opposite side is the y component. The hypotenuse of the triangle is the a vector itself. Cosine theta equals adjacent over hypotenuse. Sine theta is opposite over hypotenuse. If we solve that for the ax and ay, we have the ax is the adjacent, which equals the magnitude of a times cosine theta. Ay, which is the opposite, is the magnitude of a times sine theta. Then we just plug in our values. Ax equals 6.4 times cosine 39 degrees, which is 5.0. Ay equals 6.4 times sine of 39 degrees, which is 4.0. We can also check this by finding the magnitude of a vector, which is the square root of the sum of the squares of the components. And since we've written these in terms of sine and cosine, we can sort off the a magnitude term and find the cosine squared theta plus sine squared theta, which is just 1. So we retrieve our magnitude of a. Now here's the tricky part. A lot of times theta is not defined with respect to the x-axis, it's defined with respect to the y-axis. So here we have to be a little more careful. We recognize that the opposite is actually the x component and the adjacent is actually the y component. So sine theta is opposite over hypotenuse. Cosine theta here, again, is adjacent over hypotenuse, but the ax component is related to the sine component of the triangle. So ax is the magnitude of a times sine theta. Ay is the magnitude of a times cosine theta. So here, theta is 90 minus 39 degrees, so 51 degrees. And plugging in our values, we get that the ax component is 6.4 sine 51, which is 5.0. The ay component is 6.4 times cosine 51, which is 4.0. In general, to resolve vectors into components, we identify the adjacent, opposite, and hypotenuse of the right triangle. We use a correct trig function to define the x and y components. In general, you might have learned that the x component is always identified with a cosine and the y component is always identified with sine. You need to be careful to always identify the components in terms of opposite and adjacent sides, depending on where theta is defined. Thank you kindly, and please come again soon.